So this is the lesson where we're going to talk about finding the sizes of angles. I think this would be a good example of where to start. If you notice in this diagram, we have, we're trying to find this angle, which I said is 22.5 degrees, and actually that would be true if it's a octagon. But I measured the length of this side, and it's 1 1/32 inches, and the length of this side is 2.5 inches. So on my calculator, if I take that relationship, which if you notice is the opposite side compared to the adjacent side, so I would press second function tangent, because when you're looking for the angle, you press second function. And then we will, I'm going to need a set of parentheses for the 1 plus 1 32nd divided by 2.5. I'm just going to write 2.5. Now, when I press enter, it says it's 22.41. If you did not get that size, it's possible that you have your angle set up in radians rather than degrees. So make sure that you have the correct unit when you press your measurements. Here's another example. Oops, I thought that I had a sample of the size of the stairs, but I don't. This one I do. Okay, the height here is from 6 inches up to 29 inches. 6 inches to 29 inches makes that 23 inches. When I measure it using the other, am I in the wrong? Oh, I'm in the wrong section here. When I measure the other direction, it comes up as 20 inches. So we can find the size of this angle here if we know this is the hypotenuse. Well, I'll draw the triangle and then you'll see more clearly what I'm talking about. That side is the hypotenuse of our triangle. Then we've got the adjacent, here's our right angle down here. We can find, if we know how wide that section there is, we can find what the size of this angle is or what the size of that angle is. Now, as I said, I found that measurement here. Let's see, where did I put it? There it is. It is 20 1/4 inches. So if that size is 20 1/4 inches, and the hypotenuse we said was from 29 down to 6, which would make it, 23 inches, then this angle theta, the sine of that angle is 20.25 opposite divided by adjacent 23. So on our calculator, we're going to say second function. Now in this case it's opposite over hypotenuse, which is sine. Second function sine 20.25 divided by 23, and we get 62 degrees. Well, we can do that with all kinds of problems that you see in our lesson and in our textbook. Here's an example. We know the roof is 33 feet wide and 11 foot high. So what we can do is, if we use our calculator, And since this would be the opposite side, this is the adjacent side, so it's second function tangent. Now we have to be careful. Opposite is 11 divided by, not 33, because that's all the way across. Half of 33 is 16.5. And we find the angle of this roof to be about 33 degrees. I think there were a couple more examples in this lesson. Here we go. Let's take the hypotenuse, which you see is about 60 inches. I've zoomed in on that, and I got it to be 61 centimeters. I said inches, I meant centimeters. 61 centimeters, and the long side of the triangle to be about 48, and if you notice here, it's exactly 48. So we can do that math on our calculator. Let's see, do I have a, here we go. So we said that the hypotenuse was 61 and this long side was 48 centimeters. So for this angle down here, that would be the sine, and for this angle over here, it would be the cosine. So let's try the cosine one. Cosine theta is hypotenuse adjacent 48 over hypotenuse 61. So on our calculator, we would press shift cosine, because we're looking for the angle 48 divided by 61, and we get 38 degrees. So if this is a 38 degree angle, obviously, this angle over here is 52, and we can find that using the sine of our angle. Sine of theta is opposite 48 over adjacent 61. So second function sine, and it's the same measurements, 48 divided by 61, and we get 52 degrees, which is what we said by doing it the other way. Okay, I think that takes care of the ones. Oops, there is one. Well, no, that one was a little bit tough. Here's one that I wanted to do, though, from our work the other day. If you recall, you wanted to make your this angle from, you wanted to make this angle between these two to be 15 degrees. Okay? And if you recall, the distance from to this line was 48 inches, and the distance to this line was 36 inches. Okay? So you should be able to measure across here and figure out how long should have that been for that to be 15 degrees. And that's what we're going to be doing, those kinds of problems, tomorrow. This is one of your all-time favorites, the problem that was in your book where you were to, let's see here. You might recall this problem from your textbook. You got a piece of land here. I don't remember what exact shape it was. That's not the important part. But what you did have was a road that cut through it, where this distance was 77 feet. Well, we know straight across the road is 66 feet. So we can figure out what this angle here is, because, 66 feet goes right there. Because that angle is, the sine of that angle is 66 divided by 77. So, second function sine, you're looking for the angle, 66 divided by 77 is about 60 degrees, 59 degrees. There were some other problems that we had in our textbook and in our diagrams. Oh, this would be a good one to do. The sand pile. If you recall, it was 77.7 inches across, 6.8 inches down. So we could find this angle for the, tell you what, let's do it the other way. Let's go to this picture. So we can find and verify that that angle is indeed 41 degrees. And here's how we would go about doing it. We know the distance all the way across is 6.6 inches. And we know it's 3.5 inches. This was my sand, not yours. 3.5 inches from top to bottom. What is that angle there? Well, remember, this would be 3.3 inches because if it's 6.6 all the way across, that would be 3.3. So we can measure and see if that is indeed the size of our angle. So we'll take, what are those two sides in relation to that triangle? It's the opposite and adjacent, so that would be the tangent. So second function tangent, opposite is 3.5, divided by adjacent, 3.3, and we get 46 degrees. Now I said it measured 41 degrees. I'm disappointed that I was off by 5 degrees in my measurement. Not sure why. Maybe it wasn't 3.5 inches high. I don't know. But that does look like a 41 degree angle. And I did measure it with a protractor and found that it was 41 degrees. Let's see, was there another one that I wanted to do? Oh yeah, in our textbook. I wanted to do some of them in there. Page 210 would be a good one to do. They show some diagrams on page 210 that we can go through and find the sizes. Let's look at number 7-4, where it says the opposite side is 3.84, the adjacent side is 5.63. So if we said second function tangent, because we're looking for the angle of opposite, which is 3.84, divided by adjacent, which is 5.63, we get 34 degrees. So that's how you do these assignments.